Identify any vertical asymptotes, horizontal asymptotes, and holes. F of x is equal to the negative x plus 5 times x minus 6, all divided by the product x minus 3 times x minus 6. Well, the first thing we notice is that the x minus 6 factors cancel out if x is not equal to 6. We can simplify this to 2 times x plus 5 over x minus 3. The condition that x is not equal to 6 is important because it actually gives us a place where there's a hole in the graph. The function on the left is not defined at x equals 6 because we have division by 0 here in the denominator when x is equal to 6. The expression on the right is perfectly well defined though at x equals 6, and that's a good indication that there will be a hole at x equals 6. And we can find the value of the y-coordinate at x equals 6 by using the simplified expression. So if we write 2 times, actually rather negative 2 times 6 plus 5 divided by 6 minus 3, that's negative 2 times 11 over 3, that's negative 22 thirds, and the y-coordinate at this hole will be negative 22 thirds. So we could plot that hole as 6, and negative 22 thirds is pretty close to negative 7. So we'll have a hole in the graph at 6 and negative 22 thirds, which is, as I said, close to 7, negative 7. We also need to find vertical asymptotes. Those will occur wherever the denominator is 0, but the numerator is not 0. And so we see that x equals 3 gives us a vertical asymptote. So we'll sketch that on our graph. And let's see, horizontal asymptotes are found by looking for the relationship between the leading term, or the highest power of x, in the numerator and denominator. If we have our original expression 2 times quantity x plus 5 times x minus 6, all divided by x minus 3 times x minus 6, that behaves like negative 2, let's see, we'll have an x squared over a x times x, or just an x squared, as x, let's say the absolute value of x tends towards infinity. That's because the highest power of x is the dominant term when you square large absolute values. We can see that as well by dividing the numerator and denominator in our expression by the highest power of x and seeing that things go to 0. If we were to multiply out our expression, we would have seen what, negative 2 times the quantity x squared minus 6 plus 5 is minus 1x minus 30 on top, and in the denominator we'll have an x squared minus 6 minus 3 makes minus 9x plus 18, and if we were to multiply top and bottom here by 1 over x squared, notice that we'll have negative 2 times 1 minus 1 over x minus 30 over x squared over 1 minus 9 over x plus 18 over x squared. And as x grows to either plus or minus infinity, these terms all approach 0. They become vanishingly small. And we see that the ratio that's important is the ratio of the coefficients of the x squared term, the highest power of x. So we have negative 2 over 1. We can see that here as well. Negative 2 over 1 gives us the equation of the horizontal asymptote. So the horizontal asymptote is y equals negative 2 over 1, or simply negative 2. So on our graph, we go down to negative 2. The horizontal asymptote will be here. And we've satisfied the question. We've found the vertical asymptote at x equals 3, the horizontal asymptote at x equals negative 2, and a hole at the point where x is 6 and y is negative 22 thirds.